Hello, fellow code monkeys. Evening Fahrenheit here with what is probably gonna be a stream that's gonna be a bit on the shorter side. I reckon 45 minutes to an hour or so. I had my first day of school for the semester today, and so I've been a little busy, but I wanted to still get something done today. So here we are. I'm here with my evening calm tea, and I'm all ready to rock. So yesterday, it was yesterday, right? Because today is Tuesday. Yeah. So yesterday we talked a lot about how terrain generation is gonna work, and it turns out that it's probably gonna be easier than I thought it was gonna be. I originally thought I would have to... So the reason I went through the tile map so in depth was that I thought I would have to buffer the entire tile map somewhere in RAM and write to that and upload pieces of it. I thought that would be the only way to do this, but then after I figured out how easy it was to just loop the level, I think we can get by only writing to the map 16 table. I think that is going to be just fine, actually. So let's just take a look here at what we have. So we have this boss here. Today we're gonna make him just move to the right, and he's gonna force the camera to move with him. So you, as Mario, you will not be able to make the camera scroll left. You will just be able to go right, and you're not gonna be able to tell that the level is looping. It's just gonna keep going forever. Yeah, like this. Very awesome. And so, first things first, I don't actually know how to make the, how to force the camera to move. I imagine there's a special way you're supposed to do this in Super Mario World. I've never done it before. I've only done Extra Mario World, and as some of you know, Extra Mario World has its own engine, so it's not exactly the same thing. But let's take a look at these settings that we have here. So we can disable all scrolling. I don't think that's a good idea. Infinity, sprite spawn range. Nah, that's not what we want here. Let's see here. Variable, that's not useful. Do we have like a scroll sprite that will help us here? Special, is this even a good idea to use in a boss fight? I have no idea. I really have no idea what I'm doing. Auto scroll 1 may glitch. Why may it glitch? You may need to set layer 1 or 2. Layer 2 and or layer 1 horizontal vertical scrolling to none. Okay, what do these do? Set FG scroll to none. Okay, what does this thing do? Auto scroll. Doesn't say what it does. Alright, let's try it, see what happens. I'm sure we can just despawn this scroll sprite later if we need to. Let's see, we're supposed to set this to none, right? Let's see what happens. Oh no, it goes down! No! Damn it! That wasn't supposed to happen. Auto scroll 2, can we... What? Why does it go down? I want it to go right. Do I not get to choose? What about this one then? No, this one doesn't do anything, it seems. Unless this is the one you activate by standing on the like wing platform. I don't think this does anything. Okay, this one is useless. If someone knows how to do this, I'm gonna look so stupid, right? Special? What's special about it? You may need blah blah blah. Why doesn't it just say what it does? Auto scroll 4. Alright, let's try this one. Special 3. Oh, it's freaking out. I guess it wants to go left, but it can't. No, it looks like it tries to go right. Or is it? I don't know what it's doing. Doesn't seem very useful. Are we gonna have to make our own scroll sprite? Oh, we're going left. Oh, that's not good. Oh, that's not good. So as soon as it goes negative, we actually jump to the left even further, and basically everything explodes. And that's not great. Layer 2 scroll, that's useless. Slow auto scroll level. Y position changes speed. Oh, okay, let's try this one. Fast! Slow. Okay, let's try slow. Slow auto scroll. Slow and steady, baby. I think this is gonna do just nice. This is gonna do really well. Let's just see here. Does it load? Does it loop the level like it should? Seems like it does. I don't see any I don't see any errors. Yeah, it's working. Okay, very nice. Very nice. So I guess we're gonna use this one. And let's check, what's this? What do I have open? Oh, this is my something else. Let's go with all.log, and let's look for scroll sprite. Scroll sprites, here, it's this code, 05BCOO. That's a comment made by me, so it's definitely correct. See, so this is what we have here, right? So these are the scroll sprite codes. What is this? What does this go to? So we have scroll sprite num 14.3e. This is probably going to be in the RAM map. Let's look there where we can search more easily. No, somewhere around RAM scroll sprite. Used in scroll sprite for tracking. Huh. 14.3e, what does it say that it is? Scroll command number. Okay, scroll command, not scroll sprite. Alright, that's real nice. Be consistent with your terminology. So let's see, 14.3e. So if we, let's just test this so we know. If we zero this address, 14.3e address, then will that stop the auto scroller? That's what I'm hoping, at least. Yeah, it does. It does. So now we know that we can despawn this thing. So this is gonna spawn here. Let's actually do this. Let's load it instead of doing that and store it to ODBF. I don't think we need to address for whatever. Let's go here. And what is the number? The number is 12. That's so high. Yeah. Okay, so this is scroll sprite number 12. Okay. So that means we don't need to place this thing, I think. Well, let's look here what this does. So 12, it's gonna be this one, right? Auto scroll level. Let's look here. 2, and do we even read anything from this? How do we determine the speed? 1456, maybe? 1456, what is that? That's an index for what layer to process. No, whatever. Don't. 1456 is gonna be 0. So if we wanna spawn a scroll sprite, we would do this. 1456 layer. What else do we have here that we're referencing? 1440, I have no idea what that is. It's probably important. 1440, the starting Y position. Okay, and that is we're gonna read that, see what it is. 1440. Whatever. Always slurp your tea, fellas. Always slurp your tea. Okay, so this is 0. This value here, starting 1440, starting Y position, that is supposed to be 0. If we set it up here, yeah. Okay, so this also 0. So we're going to 0 that. Starting Y position, determines speed, 0, slow. Layer 0, layer 1. And what else do we have? 56, 40. We have 46. What is that? I think that's the position. Layer 1 X speed used in the scrolling codes. Is this just a memory thing? Does it need any input here? Compared to here. Well, let's read it, I guess. 1446. I should really use a debugger for this, shouldn't I? Because this actually takes up all the way to C8, and did we remember what that is? I think it's 128, right? Let's just use a debugger, it's gonna be easier. Unskippable intro. 1440. Let's actually speed does indeed go up to 80. Yeah. 1441, what is that? Why is it D? Starting Y position. What? With the current scroll sprite, left shifted twice and with the extra bit still added. So this is supposed to be D or whatever. Related to speed. And then speed was this thing, right? And this was a 16-bit number, so we need to make sure that we're clearing the high byte. Camera X speed. Here we are actually going to comment pretty thoroughly, so we know what we're doing. And I think now we can just write 12 to 14.3e. It's what it was, I believe. Let's see, where's that memory editor? 14.3c. Yeah, 1430, is that relevant? Probably not. It didn't pop up in the search. No, it's not relevant. So let's remove all this. And let's try just generating this thing. Does it work? And as you can see here, we're just setting the speed, we're not accelerating up to it, we're just going. So let's make it. Oh, okay, wait, it's still, even though we're just setting the speed to 80, it doesn't care. It still like accelerates up, see? Why is that happening? I'm guessing there's some initialization thing I don't know about. Let's see if we go up here again. Scroll sprites, let's see here. It was this code. And we have, it was in this first one that we have the scroll commands, and we have here on RAM scroll sprite num. Let's see where we write to that here. And when we are writing to it, we're also doing a bunch of stuff here. 1444 was that pointer timer. The timer serves no defined purpose on itself, but it's generally used for waiting a specific number of frames. Alright. So 1444 might be might be the king here. Let's read it. Yeah, why am I even doing this? I should just debug it. I don't know. I'm feeling too lazy to debug right now. Okay, timer doesn't seem to give us anything. Timer doesn't give us anything. 1444. Yeah. Like speed of scrolling codes. What could it be? I guess it's fine that it accelerates up to it, honestly. Let's just... Maybe we can remove these then. They don't seem to do anything. 1440... It's really weird that this doesn't do anything. I mean, I guess this just doesn't work the way you would expect it to. Scrolling codes. In particular, 14.4e. 14.4e? Oh, here. 14.4e. What does this thing do? Okay, let's do this properly. Let's debug. Oh, right. This is why I didn't want to debug it. The debugger is way slow because you can't skip the intro in this game. Like, look at how long this takes. Okay, there we go. 14.4e. Auto update. Okay, this thing is doing a lot of stuff. 140 CO, C1000, CO, 140. What? It's just spazzing back and forth between these two. Okay, let's back up a bit here. What if we just set this to 80? What will happen? Did it work? Wait a minute. Okay, we're gonna breakpoint this. 1446. Read. No, we're gonna go back a little bit further. Okay, yeah, that should be good. Yeah, here. So we read it, we compare it to something, and then we increment, we store. See if there's another store anywhere. Add. Store to 14.4e. Okay, but it did work to just do that. Right? No, it didn't. Because it did it in between the writes, huh? But then if this works, why doesn't it work to just write it here? Why doesn't this work then? 1447. Wait, did I make it so? I think debug makes it and then copies it. Oh, let's see here. 1440, auto update, let's go. We're interested in this one. Let's see. It's not being written? What in the world? Why is it not being written? Am I stupid? 1446? This is the main. No, I feel like I'm missing something really dumb. I feel like I'm really dumb. Guess I didn't place it. Wait a minute, is it because did I not save this in Lunar Magic? Is that shouldn't. Okay, 14.3e. Is that even? Yeah, it's totally happening here. 1446, right. Actually, first off, we're going to... Okay. Let's go way back here. And we're gonna put this breakpoint here. Here, we're writing to it from the scroll sprite, whatever, or the scroll command. Wait, we're indexing this. Hey, sprite man, what's wrong with you? Why isn't it? Wait, this isn't happening? How is it? What DB are we on? DB5? I mean, this is happening here. Oh my gosh! Yeah, this is why you should make sure that you're actually well rested when you're coding. Okay. Now I feel dumb. Here. So now we know how to start scrolling the camera at will. Wonderful. Wonderful. So let's make this a routine. Let's just call it start scroll. And that's to stop scroll, we just stz this address, right? I don't think we're gonna add defines for these because we're only going to reference them here. And the comments already explain what they do. Address here. Start scroll. And let's put this down here. Start scroll. Wonderful. So now we have that as well. Let's face handler. I guess we can start implementing that at this point. Yeah, so everything here is going to go under phase 3, right? I wonder if it's safe to use namespace in here. Probably not. So let's not do that. Attack. Let's just call these P3 attack. Let's go. Do we have a register for the boss's face? I don't think we do. Nope. What can we use? Let's just get the next sprite reg, I guess. Miscellaneous sprite table. 1594, I guess. Face. Here. Yeah. We're gonna use this. And then we go here, face X, ASLA, tax, jump, pointer, face. Let's, I guess we can, I guess it makes sense to put these, so what do we do? So I guess animation is going to be the same for all of them. I'm not sure what we're gonna do here. So obviously this line just keeps going until this goes into physics later. Yeah, let's add these prefixes here, so that we know what we're doing. P3 interaction. Throw rock is a module, so it can be here. Pounce module, bomb rush module. P3 attack. Where are we pushing something here? P3 friction, that's fine. Yeah, that's fine. Pointer, we're gonna add the same sort of limitation here, I guess. Yeah, and we're gonna change this one to sub-sub. I like sub-sub labels. BCC. So if everything goes really, really wrong, we just default to mode 0 or phase 0. And let's start by just adding P1 walk. This one can go to that's not how you do that. Let's just duplicate this one, and then this one goes to P3 attack. And this, where does it go after this? So I guess here, I actually want a return. And up here we push this address, Pia animation, like so. And then we make sure that we load this sprite index. I think I added that, right? Surely I did. Yeah, I did. Awesome. Okay, now we just need to add this here, P1 walk. And now we just make sure the boss walks, right? Let's just give him like the same speed as the camera, I guess. What is the camera speed? 8? That's so low. Could it actually be 8? I think it is. X speed. Update speed. Maybe it's apply speed. I think so. Make. No? Right. Here we also. I'm typing really sloppily today. Man, I'm quite tired. It would be a shame if we didn't actually get to the terrain generation, but I think we will. Let's see. Here, set face, and then we start scroll here. This line will only be run once, which is going to be more efficient here. I guess we end scroll at some point, but we're probably gonna have a little short transition phase anyway. Yeah, the boss is moving at the exact same speed as the camera. That's really good. It doesn't care about blocks because we didn't give him any collision code. That's great. We don't want any collision code for this. The boss is actually supposed to like destroy things, right? So now, I guess here we can just put the terrain generation here. So we're gonna make a data struct. So I think my explanation that I give today is gonna be a little daft, but I'll make sure to explain it properly tomorrow. I think now I'm just gonna write the code. Like, feel free to keep up and whatever, but my explanations are gonna be a little tame today. So terrain generation here, and what we want. I mean, I say that and I immediately start explaining. So a chunk is what we generate, right? And it's not like a Minecraft chunk, but I guess it's sort of similar. We want header 2 bytes, number of bytes in chunk. This can actually be 1 byte. Probably saves us stuff. Saves us some resources in the long run, I guess. 1 byte, number of bytes in chunk. Then we have for each block in the chunk, we have, let's just do this, chunk header for each block in the chunk. We have, we're gonna need the map16 number for sure, and that's going to be 2 bytes, right? So 2 bytes, let's just do 16-bit map16 number. And then we need X offset, and we need the Y offset. These probably don't have to be very big. We can probably merge these into a single byte. I don't know if that's actually better. It probably is. Might not be, but it also might be. I don't really know if we should do it. Let's try it. So index offset. So remember what I said about the indexes, right? To the map16 table, that the low nibble is the X offset and the high nibble is the row offset. So we're gonna make use of that to make this very efficient. So let's make a test chunk, byte header. We're going to have, this means that we have number of bytes in chunk, 3 bytes per block. Let's just generate, like, I don't know, 3 blocks, so 9 bytes. Oh, 9 bytes. And we want, what time numbers do we want? Let's make sure they're different so we can tell if this actually works. Let's do coins, why not? Coins are cool, everyone likes coin. So we want a coin, and we want this at offset 0, 0, right? And then the next one is going to be, let's generate some weird shit, man, like this tile. Do we really generate this tile? Let's get this tile, green berry, 047, and this is going to be at offset 1, so 1 tile to the right, 1 block to the right. And then let's get our favorite block in the entire game, the gray cement block, 130 dB, and this is going to be 1 block down. Let's just test everything, right? So what we need here is store input, store XY chords to 00 through 03, 16-bit numbers obviously. Store pointer to chunk in 04, and I think that's it. I think that's gonna be the input. So let's just write the code that does this. So we read this, get the header, put that in just the next one, which is 6. X plus Y plus pointer to chunk data 6, number of bytes to read. We do actually need 16-bit index here, so we're going to do rep 30, and then let's just increment past the header. Let's get a 0y, and we're gonna need to generate some sort of x here. Let's see if I can remember how to... There's an address that Lunar Magic inserts that holds the height of the level. I think it's 13d7, could that be right? Y position with Lunar Magic 3.00, this address gains a new purpose in horizontal levels by being used to hold the height of the level data in units of pixels. Okay, super good. So that's how many pixels tall the level is. So what we need to do is find the index to the map 16 table at offset defined in this. Let's do that so it's clear that it's a coordinate, not a comment, right? A comment and a comment. Commentception. So there we go. So this is gonna be pixel coordinates, right? So the first thing to do is easy. We just get this, and we so this is the column on the screen, right? Put that in. I don't know. Put it in C. Is that gonna be enough? Probably. And then we get the screen number from 1. And how do we do this? So this get this in Y, and then we just load 0, and we what do we do? If it is 0 already, no, that doesn't work. What do we do? I guess we just do this right away. Otherwise, we do this. 13d7. We add this number here. Wait, is this gonna add too much? No, it's not, right? This is also... Yeah, this is also the offset because there are 16 blocks here, right? And remember, the index is going to be halved because it's split across 2 tables. And then we do this. That should give us the index based on X position as well. And we put that in, put this in C, I guess. Like so. And then we get the offset from the vertical coordinate. That's what we need, right? Let's get some nice music. This one slaps. Let's go. If your day is ever not going well, listen to Sensei theme from Advance Wars. Let's see. Here we go with what was I doing? Right, the height here, and it's going to be, I mean, assuming that it's within bounds, right? BPL. If it's negative, we just load 0 compared to this, right? Address. And if it's less than this, it's fine. Otherwise, we load this. This forces it to be within bounds. I guess we can add something similar here as well. Here. It's gonna be very troublesome to check for being like off screen to the right, so we're not gonna do that. Actually, what we can do here, instead of doing this stuff, we just, I mean, if this is within bounds, which it should be, then we just we just add this CLC. Here we have it right here. Tags, which I guess means we should store in 8. That's the next one. 8. Store to 8. Super cool. Index to map 16 table. That should do, right? So I think we found the index. We just need to, like, here, if this is negative, EPL good X, return. If either of them are like out of bounds, we just return right away. BMI return. CMP 13D7 other VCS return here, like so. Also, we need to make sure that this doesn't have any. Now we can just clear those bits here. No, like so. Add that there. Get the index in X. That should do it. I really think this is it. It looks pretty simple, but I think it's right. Good X. Good Y, I guess. Like so. We have the pointer there. So now, I guess we actually need to have the, it would be more convenient to have the offset before the tile number, right? So let's do that. Like so, get rid of that. I don't really like how this looks, how the header just blends in here, but it is what it is. It's not a huge problem. Now we get this thing I've got here. Let's just move this down. Should we assume that the header is always greater than 0? Or should we allow this to crash if you pass it a header 0 pointer? What happens if you compare 0 to 0? I think the carry gets set, right? Fine. I guess we'll add it here. Header is there. ECS. Done. Done. Time to update music. No, actually, we're not gonna update it. This slaps. This slaps. I just want to see if this works before I go to bed. Oh man. Let's see. We load this. These are the coordinates, and let's see this coordinate here. So right now we're not gonna account for like screen borders or anything. We're just gonna put this here all dirty like. I guess we don't even need this here. Just store it to 8. Tax. Store it to. Store this to what? What do we even store it to? No, we don't. Eric, get real here. Yeah, Eric is me, by the way, if you're wondering. I'm talking to myself, like I always do. So now we increment by 1, we read the map 16 number and we store it to 7. Actually, I guess we should use a table for this. If say 1, else. I guess we should do this. Do it that way. Try hard way. Map 16 low. 70 C800. No wait, this is you should go here actually. In the else category. Shut up, phone. I'm coding. 40, 41. There. I think that's right. If SA1, you can do that, right? Well, let's see. If this works, then I did it right. If it doesn't work, I did it wrong. And we just flip it. Store to map. Right. We do have to be in this mode here. Map 16. No, it's actually better to do this, right? Definitely. So we'll load it from just one read instead of two. Map 16 low X XBA map 16 high X. Back into 16-bit mode, increment by twice, increment by 2. Loop. Now we go back here. Yeah, no. This is gonna make the code a little uglier, but I think this is still better. It's actually gonna save a brawl cycle, which is 3 cycles per loop. BCC loop. Like so. Makes the code a little... does it even make it bigger? Yeah, 2 bytes bigger. Right. Alright, I didn't actually run this code. So what do we do? What more input do we do? So we need to target like a random place on the screen in front of us, right? And we need to make sure it's actually mirrored. I guess it wasn't a great idea to do this today. I'm super tired, but let's see if we can if this works at all. Let's just feed it. Here, let's see. Let's feed it something. Test chunk. Let's get a what do we get here? Let's get one screen ahead, I guess. Let's make sure this doesn't happen all the time. Make it happen every, I don't know, this often, I guess. Add to that. And store it there, I guess. Sure. Height, let's just give it a height. 100. 100 is good, I guess. Do that. And JSR, what did I call this? Didn't give it a name. Generate chunk. This should work. We return with all regs 8-bit for sure. Oh, it flickered. He do be flickering. Did something happen? Oh, something is here. I guess that means we generated it too close. Something went wrong there. We did something. Oh, we crashed. We crashed the game. We crashed the game. Oh, yeah, that's not good. Let's see. Is this correct? If I say 1, let's just check what we're supposed to do. So 1 def. Then SA1 equal to 1. Yeah, let's do that then. If SA1 equal to 1, that could define some error. That could explain some errors, I guess. Here. Oh, he do be flickering. Oh, yeah, there's definitely something here going. Oh, there's something is rotten in the state of Denmark. I think I did generate it, but it's probably within the SIP still. So let's take this here. Let's add 200 instead. This should be fine, right? What could go wrong? I mean, I guess my algorithm down there could be wrong. Let's see if it loads anything. If it does, we're gonna call it a day and be very, very happy, I guess. Oh no! Okay, that was that wasn't good. Yeah, I think I'm too tired to fix this right now. So I'm just gonna keep going tomorrow. As lame as that is. I do think we made some serious progress here. Oh, of course! I'm shredding the sprite index. I'm so stupid. Let's see if it works now. One last test. Does it work? Does it work? Does it work? Does it work? Yes! And it's gonna generate this pattern because I'm generating it way too often, so it's like the chunks are overlapping each other. But here you see the chunk loader is actually working. So we do have some real-time terrain generation going on, which is super poggers, man. This is really cool. I'm actually really happy that we got something going here. So, we can build a level in real time. We do have the technology. And yeah, that's gonna be it for today though. Great stream, if anyone was even watching. But we're making damn good progress. So check back again tomorrow. This is going faster than I thought actually. I would have expected it to take like 5 episodes of working on the terrain generation to get here, but we're actually just on episode 2 of terrain generation. So yeah, tune in tomorrow and we'll figure this out together. Bye.